What should we expect when a massive supergiant star explodes in our immediate cosmic neighborhood? The James Webb Telescope's mind-blowing new discovery about the Betelgeuse supernova is giving scientists cause for concern. We may have been very wrong about the red giant star Betelgeuse. Does this mean that we on Earth will soon have to reckon with the explosion and serious effects of the supernova? The James Webb Space Telescope has shown us several times in recent months that our scientists are wrong. In the case of a gigantic supernova, such an error could have fatal consequences. Betelgeuse is a red supergiant star. For centuries, the star has been visible in a prominent position in Orion's shoulder. It shines clearly red, which we can even see with the naked eye on Earth. One thing is certain, Betelgeuse will explode, and soon, on a cosmic scale. It will happen sometime between now and a few thousand years from now. Since Betelgeuse has been behaving increasingly strangely, scientists have been arguing about what is correct and where huge errors may have crept in. Is Betelgeuse already on the path to supernova, or is the aging star just having a temporary bout of weakness? In 2019 and 2020, strange eclipses occurred, leading some scientists to proclaim that the star was about to explode. Others waved it away and said that this speculation had nothing to do with the real situation on the surface of the red supergiant star. So what is true? Betelgeuse is a huge star that outshines our own sun by a factor of 1,000. If we were to place it in the center of our solar system, it would reach beyond the orbit of Jupiter. Betelgeuse was not always so large. It is only since it has increasingly used up its fuel supplies that the star has been expanding. This growth in size is due to the progressive depletion of its fuel supply. In its core, the star fuses hydrogen into helium and later also heavier elements. As soon as the hydrogen in the core is used up, the star begins to strip off its outer shells and expand. This leads to a significant increase in its diameter and fluctuations in brightness. So, how do scientists want to know what age the star is actually in? On the one hand, our researchers refer to observation data from other supernovae, but this has its pitfalls, as these events are very rare. Thanks to telescopes, we could already observe supernovae in other galaxies or other corners of our own galaxy, but as is the case with stars, no two are the same. Although every star shows similar basic functions, such as nuclear fusion and certain emissions, the differences outweigh the similarities. It is therefore difficult to predict with any real certainty what is really going on with Betelgeuse at the present time. Betelgeuse supernova, dangerous for Earth. Did you know that Betelgeuse could have already exploded and we wouldn't have noticed a thing? That's because the star is around 700 light-years away from us. In practical terms, this means that its light takes 700 years to reach us. If the star explodes, we won't see it until 700 years later. This actually shows very well that Betelgeuse is so far away that there shouldn't actually be any danger for us. Supernovae eject large amounts of matter into space and produce radiation that can be devastating. But despite the violence of these events, researchers are certain that none of these ejections will reach us. However, we do not escape completely unaffected. Violent portions of matter, such as burning shreds of the surface or dense gas clouds, are lost over the distance of 700 light-years. Nevertheless, there are other particles and radiations for which this distance is almost ridiculous. These include neutrinos. These could be with us before we even see the light. Neutrinos are relatively newly discovered particles in astrophysics and are also known as ghost particles because they easily penetrate thin forms of matter. Neutrinos are everywhere, all around you now, in nature and in the cosmos. They are supposedly harmless, but in practice, we know very little about them. We have only been detecting neutrinos for a few years using special facilities located in Japan and Italy, among other places. However, neutrinos show us something that can be worrying. We are far from knowing all types of particles, radiations, and phenomena, and it is practically rare for a supernova to have exploded right on our cosmic doorstep. It is therefore impossible for us to know what else will be hurled into the air by such an event. Another pitfall is we don't know for sure how far away Betelgeuse really is from us. Measurements from the distance between the Earth and the red giant star have always produced slightly different results, and all astrophysical measurement methods are currently under scrutiny anyway. The old physics has had its day, and some crazy observations by the James Webb Space Telescope are responsible for this, showing scientists in a bitter way how often they are wrong. What if such an error is also present in the assessment of the situation around Betelgeuse, and we are in danger after all? The scientists are arguing. Is it going to explode or not? It is fascinating or even frightening how differently scientists interpret the behavior of Betelgeuse. The great eclipses of 2019 and 2020 were ultimately explained by a gigantic mass ejection. Betelgeuse ejected part of its surface into the universe, creating a dense cloud of dust that darkened the star for weeks. We are also familiar with such phenomena from the Sun. However, coronal mass ejections from our Sun are much smaller, and do not usually produce dense dust clouds. Our Sun is also still a star in its midlife, and not an aging star like Betelgeuse. Some scientists have compared Betelgeuse's ejection to an old man's cough. Betelgeuse took months to recover from this event, and some researchers believe that such unusual events could mean that the end of the star could come sooner than expected. It is not uncommon for Betelgeuse to go dark. The star has two well-studied cycles within which it dims. However, the 2019 event and the subsequent 2020 eclipse occurred outside these cycles. Scientists suspected that there may be a third cycle that spans several thousand years, and that we did not know about until now. However, we must not assume that everything in the universe is always predictable, and happens in such a way that the ideas of our researchers are confirmed. We must always expect surprises, and also that Betelgeuse will explode much earlier than assumed. The most widely accepted estimates currently assume an explosion in the next 1,000 to 100,000 years. In this context, however, recognized does not necessarily mean true. A Japanese team of scientists presented a credible and very well-researched study that caused a stir in the world of science. According to the study, the changes on Betelgeuse's surface could be interpreted in a completely different way, and the time to supernova could be significantly shortened. This team has discovered that unexpected behavior of massive stars, like Betelgeuse, can be evidence of decay processes in the ultimate final stage. Consequently, Betelgeuse's core collapse would be imminent. Betelgeuse becomes heavier and heavier and collapses. Theoretically, we know very well how a supernova works. Betelgeuse was once very likely a massive star that began its life as a hot and luminous main sequence star. In the center of such a star, nuclear fusion processes take place in which hydrogen first fuses to helium. This fusion releases enormous amounts of energy that keep the star stable for millions or billions of years and prevent it from gravitational collapse. At some point, the hydrogen supply in the core of the star is used up. Then the star fuses helium instead of hydrogen. Helium nuclei fuse to form heavier elements, such as carbon and oxygen. This phase of helium fusion is far less efficient than hydrogen fusion and creates an initial imbalance in the star. When the helium in the core is also consumed, the process continues with even heavier elements. Carbon fuses to neon, oxygen to silicon, and finally, silicon becomes iron. During each of these phases, the star continues to expand as the energy released by the fusion pushes the other layers of the star outwards. Betelgeuse is in this stage and has expanded into a red supergiant star. This bloating is therefore a clear indication that the star has largely used up its fuel reserves. In the core, the crucial point in the evolution of a massive star like Betelgeuse is the end of fusion. Once the core consists mainly of iron, no more energy can be released through fusion. Iron fusion consumes more energy than it releases, which is why the fusion process in the core stops. Without energy production through nuclear fusion, the star loses its equilibrium. The gravitational pressure, which is previously balanced by the energy from fusion, then leads to a catastrophic collapse of the core. Within seconds, the core collapses under its own gravity, reaching extreme densities and temperatures. This collapse creates a shock wave that races through the star and hurls the outer layers into space at enormous speed. This is the actual supernova explosion. When a supernova explodes, an incredible amount of energy is released, causing the star to shine brighter for a few moments, like an entire galaxy. The energy released exceeds the total energy emitted by our own sun in its entire life. The outer layers of the star are completely hurled into space. What remains at the end of such an explosion? The core of the star collapses further and can become a neutron star, or in the case of even more massive stars, a black hole. A neutron star is an extremely dense remnant in which the matter is so strongly compressed that protons and electrons fuse to form neutrons. Such a neutron star has an incredibly high density. A teaspoon of this matter would weigh several billion tons on Earth. If the remnant is even more massive, it collapses further into a black hole, a region of space from which not even light can escape. The exact nature of the remnant depends on the original mass of the star and the details of the explosion. The spectacular death of Betelgeuse will be an impressive astronomical event and will give us valuable insights into the processes at the end of the life of massive stars. It will mark the end of an era for one of the most famous stars in the night sky and herald the beginning of a new phase in the study of supernova physics. Discover many more exciting videos and subscribe to the channel now.